So hello everyone and welcome to week number 7. My God, we're almost halfway done. Oh my God, crying inside, but not outside. So we are on week number 7 and we're going to start. We just went over the test, which I probably should have recorded, but I didn't. And we are now going to start with PowerPoint number 8. So, of course, my birthday is coming up too, but nobody seems to care about that one. All right. So, anyways, so let's open up PowerPoint number 8, please.
When is your birthday?
Well, it's not during class, unfortunately. It would be nice if it was during class, but it's not. My birthday is on a Saturday.
What day is
And
it?
mine's on a Sunday.
OMG. Let's see. Today's
No
October.
celebrating.
You're going to be on the 11th, no, on the 12th. I'm double yours. I'm on the 24th.
I'm the 25th. Oh my gosh.
My sister's the 25th. That's crazy.
I love
That
math.
should be an automatic A right there.
In fact, you know what's amazing? We're going to actually talk about birthdays today in class. It's going to blow your mind. Okay. But for now, let's go ahead and open up, please, PowerPoint number 8. Okay. PowerPoint number 8. What was that?
I see you said you're spinning. You look like a yogurt.
I look like a yogurt.
Yeah, she's.
You talking to me?
You said you're like what? What?
My birthday wish for this class is 100%. Oh my God. Angela, that's the sweetest thing. Okay. My birthday wish is that you all do amazing and they give me a raise because you all do amazing, but I don't think it's going to happen. Anyways, all right, here we go. Randomness, runs, and coincidence. So class activity, look over the 2 sequences below. Don't go to the second slide, please. Make sure you only look at this one. One of them was obtained by tossing a coin 200 times and recording the sequence of heads and tails that occurred. The other sequence is fake. Guess which is which and give your reason. Now this might take 2 or 3 minutes. So I want you to look over these, and try to come up with a reason. No. Yeah, I'm okay. I'm sorry. I was trying to be off camera for that, but I guess I missed. I just have a headache. That's all. Okay. So who here has an idea for whether sequence 1 or sequence 2? Thank you, Crystal. It's very sweet. I think I'm okay. Thank you. Now, who here has an idea? Laura, you have an idea? Is it sequence 1 or sequence 2 that's fake?
Sequence 2 because there's too many repetitions. Like it looks like it's strategically like kind of the same ones too many times. I don't know how to say that statistically speaking.
Okay. Does anyone else have an idea?
I have an idea.
Go for it.
I actually think the complete opposite. I think the sequence 2 is real and sequence 1 is fake because each of these coin flips are independent of each other, meaning that there will be rows of like 10 of tails or 10 of heads.
I agree with whoever that was. Sequence 1.
That was perfect. That was awesome. So Lori, sequence 1. Well, let's go through the slides because the slides kind of actually explain it.
Okay.
So most people classify the sequences above incorrectly. because they don't have a clear idea of what random means. Yeah, that was amazing, Brooke. That was really pretty. That was awesome. I'm surprised Angela hasn't said anything, but that really wasn't. Oh, never mind. No, there it is. Okay, so so people don't really have a clear idea of what random means, right? Lori,
Slam. Wow. And it's my birthday and everything.
yeah. So Lori, the first one looks on the surface to be more random because the H's and T's are kind of, interspersed, separated apart.
Yeah.
But as Brooke pointed out, if it's truly, truly random, then you should expect to have a number of H's or a number of T's in a row from time to time. Because if it's truly random, well, we'll actually go into the math about that. But the word random, okay, which of the following is the best interpretation of a random sequence of events? 1, the events follow an unusual order. 2, the different events are thoroughly mixed up. Or 3, which event occurs next has nothing to do with which events occurred before it. 3. This is truly what random means. Okay? Random means that the events think about it in terms of memory. If I flip a coin, the coin has no recollection of what came up just before, right? Yes, no, maybe so. So every flip is essentially a new situation that had nothing whatsoever to do with what came before it. Which means if I flip a coin and it's heads, what's the likelihood that the next one's going to be heads?
I see 50%.
50%. And if I get 2 heads in a row, what's the likelihood the next one's going to be heads?
Still 50%.
Still 50%. In other words, every time it's like starting over again. Okay, does that make sense?
Yeah, I still don't see how that has anything to do with why.
So
you
we're
read,
so
you're
we're-
getting to that.
we're getting into it. So when people are asked to write down a random string of letters or numbers, they tend not to repeat the same item very many times in a row. Okay? Sequence 1 above, for instance, is very typical of what people will construct if they're asked to simulate this. As you may have noticed, Lori, I think you noticed this, the sequence never has more than 4 heads or 4 tails in a row. If you look at the sequence here, you will never see more than 4 heads or 4 tails in a row. Whereas down here, let's see what we see. Let's see some of the things that I just happened to notice. Let's take a look. 1, 2, 3, 4, 5, 7 tails in a row. 5 tails in a row. 6 heads in a row. Look at this. THHH, 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 THHH. The same pattern 4 times in a row. These are things that if you were doing it at random, you'd probably intentionally try to avoid. Oh, I can't have too many H's or T's in a row. That's not random. So let me not do it. Oh, I can't have the same occurrence over and over and over again. That's not random. But it's exactly the opposite. It is random. If it's truly random, anything's going to happen eventually. Does that make sense? You guys ever have you ever have an iPod? Who here had an iPod at some point in their life?
Yes.
Makes
Yeah.
it-
Yes.
You ever hear the same song twice?
Yes.
Very
Really?
seldom.
Hardly.
Huh?
On the
Barely
first
ever.
The first generation, seldom.
Oh,
Second
because-
generation and third generation, not so much.
That's, oh, I'm sorry, I didn't mean to do that. Hold on, sorry. So, oh, I lost all my info. Okay, anyways, well, we'll get to that in a minute. Anyways, the reason people are very poor at recognizing randomness is due to 2 closely related erroneous beliefs known as the law of small numbers and the law of averages. You might have heard that term. Oh, by the law of averages, there's no such thing as a law of averages. It's not a mathematical or a statistical idea. There's no such thing as a law of averages, even though you hear it, because people don't know what they're talking about half the time. You know, often I hear, oh yeah, that thing grew exponentially. Or I don't know, other things out there in the world that just make absolutely no sense. Same song for 3 hours. Well, this is not Pink Floyd or Rush. So very rarely you're not going to hear the same song for 3 hours. But anyway, of course, Laura, they might not know it. David, you know what I'm talking about, right?
Rush.
Rush, David?
Rush,
Lori? Come
yeah,
on.
and Eddie Van Halen passed away today.
I know.
Eddie Van Halen did pass away today. What the hell's a walk? Oh,
You're killing me, dude.
Hey, Jose.
Watch Back to the
Google
Future.
it.
Google it.
wow. Oh, Jose. I remember a time when our phones were the rotary phones. You know, we had to do this to dial. Do you guys even know what those are?
I do.
Yes, I
Not
used to
that
have a pink one.
We still have one at my mom's house.
That's crazy.
Well, my sister's house now.
That's crazy talk. Anyways, so what is the law of small numbers and what is the law of averages? Okay, the law of small numbers. People often think that even small segments of random sequences should reflect the overall proportions. But we've talked about this. I got you, Angela. I got you. We've talked about this. Stabilization only occurs after a large number of trials, correct? In the small run, anything can happen. There is no expectation for stabilization for a small number of trials. The law of small numbers is completely false. It's just not true. It makes no sense. There's no such thing as the law of small numbers. Okay? It's only in the long run that you get stabilization. The law of averages is even worse because so many people think the law of averages is true. The law of averages says, well, if you got a lot of heads, then it's got to be a lot of tails coming up because by the averages, it's got to balance out. There's no such thing. There's no such thing. Every flip has no memory of what came before it. Oh my God, what's the whole conversation going on there? I'm not even part of it. What's going on? I'll take the earrings. What are you talking? I don't understand what's happening. What? You guys are weird. Okay, so gotta go. Okay, bye. Hope everything's okay. All right. Anyways,
I think it started over a song. I'm not sure.
Oh.
Because you mentioned iPods and then they were talking about songs and yeah.
well, okay. I don't understand what's happening right now, but just you should all go have an orange creamsicle and relax. Orange creamsicles are the best, and everyone who's never had an orange creamsicle does not know what they're missing out on.
Affirmative.
Orange creamsicles are the best food ever. Anyways, so no one's commenting on that, by the way. I noticed. Has no one here had an orange creamsicle before?
Yeah, they're good.
Okay, someday when I'm on death row, that's gonna be my last meal. Just so you guys know, orange creamsicles are the best. Okay, there's nothing on this planet with a better taste than orange creamsicles. I just want to point that out and move on. And okay, let's move forward. So,
Except cheesecake.
no. Orange creamsicles are better. Now, orange creamsicle cheesecake. Now that's something. But anyways, move on. Okay. So, the reason why people think that the law of small numbers and the law of averages govern randomness is because if it's truly random, then if I have a bunch of H's, I should have a bunch of tails, right? It's got to be random. It's got to be 50-50. It's got to balance out. But there's no such thing. Every flip is independent of what came before it. Which means that long runs should be expected because by the law of large numbers, or just in general by the fact that there's no memory, as we're going to see in just a few minutes, the same result over and over again is a statistical probability if the number of trials is large enough. So, all right, let's get back to focusing, guys. Okay. So what is the name of the correct law that describes how things balance out in random situations? It's not the law of small numbers, and it's not the law of averages. What is it? It's the law of large numbers. Okay. Now, let's think about the law of large numbers in this context. So, you have a total of 200 tosses of a coin. How many of those tosses do you expect to be tails? 100 tails.
100?
100 tails, right? You expect to have 100 tails, correct?
Yes.
After each of those tails, you can have a heads or a tail, correct?
Yes.
How many of those do you expect? Oh, crap. Heads or tails?
You just gave us the answer.
Yeah, shut up. All right. So how many of them do we expect? How many of those hundreds do we expect to be heads?
Maybe
50.
50?
50-50.
500.
Yeah, 50. Now, after that first head, it could be a head or a tail. How many do we expect to be heads?
25.
25. After that second head, it could be a head or a tail. How many do we expect to be heads? Approximately.
13 and a
12.5.
About 12,
That's 10.
about 12.5.
12.5.
12.5. I have a question.
Yes.
Does that also go for T?
Yeah, yeah. Heads or tails, same thing.
Okay.
So how many heads do we expect to get after those heads?
Half of that. Half of 12.5.
6.25.
Oh, yeah.
And how many heads after that?
Half of that.
About 3, right? Approximately 3. So how many times in 200 flips should we expect to get 5 heads in a row or more?
One,
5 or more?
4, 5.
3.
About 3. It should happen about 3 times.
That's not a -3, right? That's
That's
approximately.
approximate.
Okay.
Right? So we expect in 200 tosses to have a run of 5 or more heads about 3 times.
So what you're saying is like you can have 5 or more consecutive heads about three times in the whole sequence?
That's what you should expect. Right? That's what, or more, right? How many times are you going to get 6 heads?
6 and a
About,
quarter.
about
1.5.
About
1.2.
yeah, 1 or 2 times. Right?
Say that, repeat the question.
How many times would you expect to have 6 heads in a row if you toss 200 coins? The answer is it should be about 1.5 times, 1 to 2 times.
Did you get that?
Half of 3.
Oh, half of 3.
I just kept having it. So what I wrote here is basically the idea for all of this stuff here. And I don't want to go through one at a time. I just kind of gave you the final answer.
So the answer for that is 100 or 1.5
For what?
for the question, for that question.
So the question was, how many times would you expect to have 6 heads in a row? It's about 1 to 2 times. Right? Because that's the math. 1.5, 1 to 2 times.
So then what law governs the randomness? Because
The
you
law-
said there's a law that governed it, but you never told us which one it was.
The law of large
Large
numbers.
numbers.
The law of large numbers.
So
Thank you.
this is law of
Large.
large.
Oops.
And then you said the answer was what? 1.5?
Well, the answer for, well, I just asked my own question. I said, how many times would you expect to have 6 heads in a row? The answer is 1 to 2 times. All of this stuff I just went through is basically all of that. So don't worry about it. It's only because in the interest of time, it's just faster to do it that way. And here's the example that I was mentioning earlier. The iPod Shuffle first came out. So it generated playlists by randomly choosing songs from the library on the iPod. But many people complained that when a new playlist was generated, it picked the same songs as before. So Apple actually made an algorithm to make them less random. But in actuality, what they did, right? People thought by having the same one multiple times that it was that it wasn't random enough. But the truth of the matter is, what did we just see? You should expect to get the same one multiple times. Because if it's truly random, then that should occur. I actually have a friend who's a computer programmer, and he makes games for gaming companies, like on the PlayStation and all these different platforms. And he told me once that when he was designing a game where someone had to jump over a pit, he had to learn all the physics involved so he can program it accurately. And when he did that, he said the characters didn't seem realistic. So they had to change the code to make it more realistic, even though in reality, it wasn't as realistic as it gets. Just people weren't expecting that. What is that? Is that an iPod Shuffle? You actually have one? That's crazy talk. When did that come out?
Who has one?
Yesenia.
Oh, nice.
I had one, and then you had the one with the
Angela.
screen on it.
Cool story. All right, let's move on. Next question. This one is a little tough. Well, not so much tough, but the answer is a little surprising. A die with 4 sides colored green and 2 sides colored red is tossed 6 times. Without answering this question, which of these 2 patterns is more likely? Again, a die with 4 sides colored green and 2 sides colored red is tossed 6 times. Which of the following sequence do you think is more likely?
The green colored side?
Well, I'm not saying.
2.
Oh, 1.
Hold on.
Number 2.
Don't say the answer, or don't say what you're thinking. Let people think about it for a few minutes.
Sorry.
It's okay.
But you asked us a question.
Yeah, but I said don't answer yet. I literally said those words. Don't say the answer until people. I'm recording it. I can play back. Anyway. So the question is, which of the following sequences do you think is more likely?
Can we say the answer now?
No, not yet. I want to give people the chance to think about it and to come up with a logical reason for it.
I'm not there yet. None of this is logical to me yet.
Yeah, me either.
Is this how they like figure out like which COVID cases are going to become like more serious or whatever? It's just I'm trying to see the practical application.
That I can't say. That's above my pay grade. When Fauci calls me, I tell him what I know, but he makes the ultimate decisions. So
I imagine it has something to do with this kind of statistics.
well, if you don't think that they actually do statistics to calculate some of these things, I mean, that's probably all they do.
Yeah.
But we're not at the point where we can analyze this stuff.
No.
I mean, no, I'm saying this class is not the point. We haven't done enough chat.
I just have to inspire my students to like what they can do with this type of career.
You didn't teach yet, Lori?
No, just with my own kids.
It's like your own kids. How many kids do you have?
3.
3 little Loris.
No, 2 boys, 1 girl. Just 1 girl, 2 boys.
Okay. We will save to 2020. Too late. Okay. Anyways. So, who wants to answer? Who here thinks that the first sequence is more likely? Got one hand up with Miriam, but I don't see everyone's hands. So you got to talk verbally.
Yesenia has her hand up.
Yesenia, you think the first one is more likely? Okay. And Miriam, anyone else? All right, who here thinks the second one is
David.
more likely? Where's Brooke when you need her? Brooke, what do you think?
I don't know. Honestly, I don't get this one.
Okay, well, the question is, you have a die, and rather than 1, 2, 3, 4, 5, 6, you have green, 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 red, red. And you flip it 6 times. And the question is it more likely to get green, red, green, 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 red, or green, 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 green? Which one is more likely? I have some people say the first is more likely, and I have some people say the second one is more likely. Well, it can't be neither unless you think they're equally likely, which is perfectly fine. You know, they could be equally likely. Of course, there's more greens than reds, right? 4 greens, 2 reds, so. So the answer is,
I'm just thinking of the 50-50 thing. The
but it's
chances
not
of-
50-50. This is a die with 4 greens, 2 reds. So it's the probability of green on any one flip is going to be 2/3. And the probability of red on any one flip is going to be 1/3. So the answer is that the second one is more likely.
I didn't have the right explanation.
Well, great. So you said 2 after I said the answer. Congratulations there. Way to go, Crystal. Okay, so the answer is that the second one is more likely. Oh, I didn't hear my answer. Everyone say hi to my mom. Oh, where's your mom? I don't see your mom. Where's your mom? Put your mom on screen.
Where's mom?
I don't see her. Hey,
There she
mom.
is. Say hi.
Hey,
Hey.
how's my girl?
Wow, she came and went. Okay. Anyways, so someone explain why the second one is more likely.
Isn't there more green, like 4 sides painted green and just 2 sides painted red?
Yeah.
So the
It
green
has. Oh, sorry.
is
Well, your first instinct might be that I should get green 2/3 of the time, and I should get red 1/3 of the time. And that's true. You should get 4 greens and 2 reds. But that's not what the question is asking. The question says which one of these 2 specific sequences is more likely. So let me ask you a question. On flip number 1, do I expect to get a green or a red?
A green.
A green. Either one. Now ignore that flip. It's over. On flip number 2, do I expect to get a green or a red?
Still green.
Still green. Flip number 3, green or red?
Green,
Green. How about 4?
green,
How about 5?
green,
How about 6?
green,
Someone say red?
green.
Green, okay. You're more likely to get a green on any one specific flip than red because green is more likely on every one of them. So why is it more likely to get 4 greens and 2 reds than it is to get 6 greens, but less likely to get this than that? And the answer is because there's lots of ways of getting 4 greens and 2 reds, as we're going to see in a later chapter. In fact, we can actually answer that question now. If I have 6 flips, how many ways could I get 4 greens? 6 flips. How many ways can I get 4 greens? How do I answer that question?
Well, how many ways?
How many ways could I get 4 greens? 6 flips. How many ways could I get 4
Oh,
greens?
that the factorial thing. Right?
Yes. It's a factorial problem. It's combinations.
So when after the first one, there's still 5 chances, right? After
Well,
the
no. You're confusing 2 different things. Every flip is independent.
Oh, that's right.
Okay. So it's 6C4. So the answer is 15. There's 15 ways to get 4 greens. So it's more
I have
like,
a question.
yeah.
Go ahead.
No, go ahead. Go ask a question.
It's not regarding this, so finish this and then I'll ask you.
So there's there's 15 ways to get 4 greens and 2 reds, which is why it's more likely to get 4 greens and 2 reds. However, it's more likely to get 6 greens than it is specifically that sequence of 4 greens and 2 reds. All right, I'm just gonna take some Advil. Hold on.
And the reason it's more, in answer to the last thing you said, the reason is because there's more possibilities, more ways to get green.
There's 15 ways. There's 15 ways to get 4 greens. But there's only one way to get this sequence of 4 greens. Red, green, red, green, red, green, green, red. It can only happen in the order green, red, green, 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 red, and so on. Anyways, sorry. So I want to go just to the birthday situation. It's gonna be a lot of fun.
Why not?
This is gonna be a lot of fun. Don't read it yet. I'm just gonna ask a question. I'm actually gonna ask 3 questions. And I want you to answer these 3 questions. And these 3 questions, 2 of them are going to be really, 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 really easy. So don't overthink. The answers are basic. How many days of the year are there in a regular year?
365.
365. Let's even pretend that it's a leap year. So there's 366 days. Okay. How many people must you have in a room before it is 100% guaranteed that 2 of them have the same birthday?
I'm sorry, say that again.
How many people must you have in a room before it is guaranteed 100% chance that 2 of them have the same birthday?
730.
No, you know, a lot less than that.
364.
7.
Where'd that come from? 367.
Just an extra day from
Yeah.
the 366.
Excellent. You have 366 people, then it's possible that every one of them has a different birthday, correct? But once you throw in the 367th person, now 2 of them have to share a birthday. Do you agree? Now,
Yeah.
on the other end of the spectrum, what's the most number of people you can have in a room before there's a 0% chance that 2 of them have the same birthday?
365.
No. We want to have it impossible that 2 of them have the same birthday. What's the most number of people you can have for it to be impossible that 2 of them have the same birthday?
2?
If 2 people were in a room, could they have the same birthday?
One.
1. Once you have 2 people, there's always a chance that they have the same birthday, correct? So for there to be 100% chance that 2 of them have the same birthday, you need 367 people. For there to be a 0% chance that 2 of them have the same birthday, you can only have 1 person. The question is, how many people do you have to have in a room before it's an even chance, 50% chance that 2 of them have the same birthday? How many people must be in a room before you have a 50% chance that 2 of them have the same birthday? Now, unless you've seen this before, you're not going to guess.
188.
The answer,
23.
23.
Wait,
That come from?
If you have 23 people in a room, there's a 50% chance that 2 of them have the same birthday. Now, in this room right now, how many people do we have? Is there a number anywhere?
33, including you.
33 people. So that's more than 23. So I'm going to say that 2 of us have the same birthday. So what I'm going to do is I'm going to put my birthday in there. And I want everyone else to do the same. And let's look for a pair. Because I say that it's more likely that 2 have the same birthday. So let's see. Do we have a pair anywhere? Keep going, everyone. Don't be shy. If you see one of yours, come on, we need more people. We need everyone to participate here. October 11th, don't forget. We have a pair? Come on. This is going to fail miserably if we don't.
We've come close.
Well, close is only good in nuclear weapons and hand grenades.
I'm on the way. All right, Kimberly.
By the way, if you squeeze the fatty part between your hand, your thumb, and your index finger, and go in the circle.
24 people. Uh-oh. Are people not here but are pretending to be here?
No, they're here.
I don't know. That's 25. There's still 8 people. 26. Take attendance. That's a good idea. I think I'm going to do that. Take attendance. That's a great idea. Let's have a mid-class attendance check right now.
Busted.
Melissa,
Here.
Kimberly,
Here.
Lyra,
I'm here. Sorry, I was in the chat and I was trying to exit.
okay, Arpine,
Here.
Celeste. Celeste is here. Wendy,
Here.
Veronica,
Here.
Angela.
Here.
Of course, Angela's here. She's never going to leave. Lori's here. Miriam.
Lori left. She's gone.
Oh, I don't like Lori anyway. Crystal. Crystal's here, right? Crystal,
She's here. She's here. I don't know why she's not talking. She's here.
where? I don't see her. Okay.
She's right there. I don't know. Yeah.
Okay, Giselle.
Really bad audio. It's embarrassing.
Giselle's here.
Okay, Sarah.
Here.
Andres.
Here.
Daisy.
Here.
Heidi.
Here.
David.
Here.
Raina. Raina. Uh-oh. Going once. Going twice. I'm here. Amanda.
Here.
Leslie.
Here.
Sochi.
Here.
Hasmik.
Here.
Yesenia.
Crystal Flores said, "I promise I'm here."
Oh, okay. That's good to know. Jose.
Here.
We got you, girl.
Valerie.
Here.
Isabella.
Here.
Brooke. I know Brooke's here.
Here.
Henry.
Raina's, excuse me, this is Terry. Raina's here. I see her.
You see her physically or you see her icon?
I'm here too, Henry.
Just the icon, yeah. Just the icon.
Icon is not enough, unfortunately.
Oh, okay, okay.
Thank you, though.
Sure.
I'm here.
Henry,
Henry's here. Yeah, I'm here.
Patty,
Here.
and Jennifer.
Here.
Raina, you here? Okay, well, I was hoping to bust more people, but I'll take one. Okay, so let's continue. So this is called the birthday paradox. The birthday paradox is the fact that we have a very unexpected result. That 23 people is enough to have a 50% chance that that 2 people have the same birthday. And the question is, why is that the case? Just by the way, I was a little surprised that we didn't have the same birthday and no 2 people did in our class, because usually it happens that people do, especially with 33 people. But sometimes it doesn't. That's just the way it is. So the question is, do you only need 23 people to have a 50% chance of having the same birthday? And the answer is as follows. How many days of the year are there that people could have the same birthday? 366 of them, correct?
Is it 365?
Well, a leap year as well.
Okay.
So there's 366 days that it can possibly be. Now, for two people that have the same birthday, you got to take a pair of people, two people, and compare them, right? How many ways are there of taking two people from 23? If I have
Subtract.
if I have 23 people, how many ways can you pick two of them?
Oh,
506.
Where do you get that from?
I multiplied 22 times 23.
And does the order matter here?
no.
Right? Is this a combination or a permutation?
It's a combination.
It's a combination, right? So from 23, I think it was 23. From 23 people, we're going to take two of them. And the question is, how many ways can we get that? And the answer is not 23 times 22, but 23 times 22 divided by 2, which is 253 possible pairs of people. So even though there's only 23 people, there's 253 pairs of people. And it's the pairs of people that are really the key. Because we need a pair of people to have this birthday or this birthday or that birthday. So we got 253 chances of checking whether or not two people have the same birthday. So because of that, it's a lot lower than what you would normally expect. That's the idea of the birthday paradox. Why is it called a paradox? Because the outcome is not what seems reasonable, even though mathematically that's what the result is. And I love paradoxes because those are the ones that really make us question what we believe and clear up our thoughts and basically improve our thoughts. And we don't got to do the last one because it's just another example. So we are done with chapter 8. So we're going to have a quiz next week on chapter 7. Not chapter 8, but chapter 7. We'll have the quiz, I don't know, I could probably put it up Tuesday of next week and you'll have 48 hours or something to do it. But
Chapter 7, you said?
chapter 7, yeah.
I have a question.
Yeah.
On slide 7, where you got green is 2 out of 3 and red is 1 out of 3.
Yeah.
How did you get the denominator as 3? Is it because there was 6 of them and you just divide both of them?
Yeah. I reduced terms.
Okay.
Yeah.
I got you.
Thanks. So are there any questions on this? Okay, so the chapter 8 homework is up because the chapter 8 PowerPoint's up. By the way, the chapter 7 solutions are also up. I put them up earlier so you can go over them and check your chapter 7 answers because I'm that good. I got it in advance for you. You're welcome. Surprised Angela didn't say anything, but that's okay. So anywho, if there's no other questions, I will see you all on Thursday.
Bye.
Thank you.
Thank you.
Bye,
Thank you. Bye.
Thank you.
Bye, everybody.
Bye.
Thank you.
Thank you. Question?
Yeah.
Professor, the quiz is on chapter 6 and 7.
No, just 7. Just 7. Yes.
I was wondering how many points each question is for the test.
So each question was 20 points because there were 5 questions.
Okay.
And I tried to break it up into roughly equal parts. But yeah, each one was 20 points.
Okay, thank you. I just wanted to know.
No problem.
It's gonna be like that for like future tests as well, right?
I think so. I think it's fair.
Okay,
I don't
thank you.
I don't see why not.
Okay.
You're welcome. And then there were 5. Well, I know Yesenia and Crystal are here. And I know
Yes.
here.
So I was looking over my exam because I was doing corrections as you were explaining them.
Yeah.
So
Here, why don't you?
Huh?
Bye, Crystal.
Oh, I'm sorry. I'm still on. I thought I was
Yeah,
off.
go away. We don't want to see you. Go. Yesenia, why don't you share your screen if you don't mind? Do you have you have your exam on the screen, or I can just see it?
it's on paper. So I
Okay.
know I made some mistakes, but like, so if they were worth 20, wouldn't I have gotten like 80? And you gave me 78.
Well, I gave you partial credit for things. It wasn't like all or nothing for questions.
Oh.
You could have had partial credit, where I took off a few points here, a few points there, a few points there type thing.
Yeah, because for number 3 I didn't put 50, and it's because I didn't read the whole.
So I think I took off 3 points if you didn't put 50 down.
You took off 3 points?
Yeah, I think I took off 3 points for that one.
Okay, and then I know I didn't do the 10 factorial because I don't know why my brain didn't register that. So I know that's wrong.
Okay.
And then B is wrong as well because I didn't register that. I got C though. So if I got B and A wrong, 20 divided by 3 would be.
No, it wasn't exactly, because you can't do the 20 divided by 3. So I think I did 686. I don't remember offhand what my rubric was, but I think it might have been 686.
686. Okay, so 6. And then take 3, so that's 17. And then, yeah, but for like, that was it. Those were the only questions I got wrong. So I guess my math isn't adding up.
Well, do me a favor, because I don't keep emails. Therefore, I've deleted your test already.
Ah, man, and you're telling me this now? I could have cheated, and you're telling me this now?
Yeah, it was kind of silly of me, right?
No, I would never cheat. It's honesty all the way, 100%.
But if you want to resend your exam, I can regrade it and see what I would have given you this time around.
It's just too much work for you, and I get that you're tired. You have a headache right now.
Yeah, that's me all the time. So I'm not saying I'm going to do it today, but I'm saying I'll get around to it.
You'll get around to it.
So if you want to do that, I can relook it over if you'd like.
Okay. Yeah. I mean, I just wanted to know why I got what I got, because now that I look at it, yeah, it makes sense why I didn't do as great as I thought.
I mean, listen, the grading wasn't exactly 1/3, 1/3. So if you're within 2 points, it probably means I graded it the way that I graded it correctly. And it's just, I assigned different points for each part than you are currently doing it yourself. It wasn't 6 and 2, 6 and 2/3, but it could have been 6, 8, 6, or whatever. And I graded each one accordingly.
By the way, you didn't stop recording, so you might want to like clip